Hello, in this short video I'm going to show you an issue with TLS1.3 and Google on ProxySG forwarding host. So I've got here in my config I have got a forwarding proxy, so this is a child parent proxy deployment, and my parent proxy is this guy here, 10.10.10.157. When this gets created on ProxySG, the proxy spits out a forwarding health check monitor. Here under health checks, which is here. There's the forwarding object, and by default, the proxy will create this. It's just a TCP health check. So basically, the child proxy would wait for the TLS handshake, the three-way handshake, to be established before the child proxy could mark this parent forwarding object as healthy. However, when you change this to HTTPS and you point this to Google, so you're making now not just a three-way handshake to the parent, you're making a three-way handshake, SSL handshake, and then you actually send a GET to Google through the parent and back, and that's how you monitor the availability of your parent. Then there is an issue on 7.3 code when you use TLS 1.3. So if I go to SSL client, these are the settings that the proxy will use in SSL handshake on self-originating traffic, which this is the case, right? This health check didn't come from the user, it's originated by this child proxy. And notice that when you upgrade to 7.3 by default, TLS 1.3 will be enabled. Now, interestingly, when for some reason, when you go to Google and you allow to do TLS 1.3 without the SNI, you get back a self-signed certificate from Google, so no chain, right? And there's no, the trust cannot be validated on the proxy, and the common name by Google will be set to invalid2.invalid. Now, if you do the same thing on TLS 1.2 to Google, Google behaves differently. And here it sends the full chain. Here you can see the chain of 3 certificates, and you can see that the common name is correctly set to wildcardgoogle.com. So that means that the SSL client on a proxy can validate the chain and the certificate with TLS 1.2 fine. However, with TLS 1.3, that validation is going to fail. So what that then means is that if we go back to the health check, and you can see that right now this health check has failed, right? If I was to run a packet capture on this proxy, it would basically show me that after the server hello with the certificate comes back, the handshake, fails, and the proxy closes the connection because it can't validate that invalid2.invalid certificate, and that's it. And therefore, this parent is now marked as unhealthy and not being used by this child proxy. So there's various tactical solutions here. One of them, the obvious one, of course, is go to SSL client and take TLS 1.3 out, and then if you go to health check, it's going to go up. Let me actually run a health check because I don't want to wait. I need to do it from here. Let me go back out and run the health check here, and yeah, there you go, it's back up. The other fix, of course, is, well, don't point this to Google, point it to something else that doesn't behave like Google. Going back to why Google behaved the way it does, we don't know. However, we cannot only blame Google here, because it works fine if the SNI is provided. So what's actually happening on a proxy, and this is being addressed by engineering. The proxy, when it sends the SSL in a client hello, it doesn't provide any SNI. And that is because in the current version of code, the proxy looks at, it tried to put into the SNI the value from the actual forwarding object, which in my case is IP address. And of course, as per the RFCs, you can't have dotted in a decimal number or the IP address in the SNI. It has to be NFQDN. It has to be a host. So therefore the SNI is set to null, and therefore there is no SNI, and therefore Google sort of in TLS1.3 go, well, no SNI, I don't know what certificate to serve it you, I will serve this this invalid one. In the future releases of a code, the proxy is not going to be looking at the forwarding object to get the SNI at all. The proxy is going to be looking at what's configured here, and it is going to use this, and it's going to inject this value into the SNI. And of course, if we go back to our Google test and we just run it like this, we know that this is going to work fine, right? So here I provided the SNI and I got the valid certificate common name, and here is my 3 certificate chain, and everything has worked great. The potential other workaround that can be employed before the new code comes out, of course, it's to disable SSL server certificate validation in the CPL in a proxy policy. And that then means that proxy gets back this invalid to .invalid self-signed certificate, but the proxy won't care, and it will trust that SSL connection and the SSL handshake will proceed, and then the proxy will send the get will come back, and the health check on the parent will be up. And that concludes the demo. Thank you.